Okay, now let's do this problem number 3, which we also did in class, but we didn't spend so much time on it. So the first thing to do here, since we talk about subsidy as the opposite of a tax, and since we practice doing a tax when we have the actual demand, the demand curve, which we call the inverse demand curve because it's P in terms of Q, let's convert this demand equation, Q as a function of P, to an equation that has P as a function of Q, which is our traditional demand curve, right? So that will mean that the demand curve will be PD equals 6 minus 0.5 Q. And again, what I'm doing here is to taking this equation and solving it for P in terms of Q. Okay, and now let me get rid of this so you can still see the problem. Now the supply, we will do the same thing with the supply, which is Q with this one, and that will be PS is going to be equal to 0.5 Q. And again, what we did here is we took this equation here and we solve it for P in terms of S or Q. Okay, now we're ready to solve at least for the equilibrium price by making these two things equal to each other. 6 minus 0.5 Q equals 0.5 Q, so Q equals 6 and P is equal to $3. That's the equilibrium price and the equilibrium quantity. Now what about the subsidy? Well, we have a subsidy of $2, and again, the subsidy is the opposite of a tax. So if we add it to the consumers, which is actually in the case, in this particular case, the problem tells us that we are going to add it to the consumers. So every time the consumer buys something, they get a price subsidy, so essentially they're getting $2 back. So the consumer is going to get, it's going to pay whatever price it is minus those $2. So the cost of per mile for a consumer is going to be reduced by exactly $2. And now we write the rest of the equation here. And now we can take that 2 and bring it to the other side to have our new demand equation, which looks like this. And again, what we just did here is to shift the demand curve instead of to the left by the amount of the tax, we shifted to the right by the actual amount of the tax. So anywhere, this is D1 and this is D2, anywhere vertically between these two curves is going to be exactly the amount of the subsidy, which is $2. Alright, so that's essentially what we did. But I'm giving you the rationale for it by telling you that you can just simply put it in the demand equation by subtracting it from the price, since essentially the government is actually reducing the price of every mile by $2. But in any case, now we have our new supply curve, and we put it, we make it equal to our new demand curve. We make it equal to our supply curve, which didn't change; it's still 0.5 Q. And now we solve for Q, and we know that the new Q is going to be equal to 8, and the new price is going to be equal to 4. So the effect of this subsidy, again, a tax usually reduces quantity. A subsidy, since a subsidy is a positive tax, is the opposite of a tax, what it does is it increases quantity to 8. And in this case, it's going to increase the price to $4.